Okay. So I just want to know, do I need to speak in the mic for that to record properly? So I will need the mic, or can I just project?
You need to talk into the mic.
I will need to talk in the mic. Okay, good. So I'll hold it. So my name is John. So I'm a developer advocate with AWS. So I've been with them for over, getting to 4 years now. So we'll see what that means for me. 4 years, that's a long time. So I just joined in that role though. So maybe about a year ago, I moved into a developer advocate. I was started as an SA, and then they said I talk too much, so they shipped me into training, and then they said I talk way too much, so then they shipped me into dev advocate, so I can go and do conferences and then these kind of talks all the time. So that's basically what I do. So build demos, talk about the technology, and then try to build more demos so I can learn deeper about the technology, because that's the hardest part of my job, is staying current. And especially when there's stuff like reInvent that happens. So for anyone that doesn't know what reInvent is, that's our large conference that happens every year. So last year, so that's reInvent. So last year, 65,000 attendees. So that was in December of this year. 3,000 sessions. Every single one of the sessions are on YouTube. So if you want to go and watch them, you can watch them all and then waste 3 years of your life. Why do I say waste? It's not a waste for this year, but next year it will be, because you're going to be obsolete. But there's 3 years of content of reInvent sessions. So if you watch it for 3 years in a row, you'll be able to end it all. Don't do that. So instead, today I am going to try to talk about certain topics that are going to be of interest to you. So there were 250 different features and services that were released at reInvent. And I forgot to remodify that slide, but I said we will only cover 7. That's true. I started with 7 services, and that was this morning. And this afternoon, I was at 82 slides. So something happened. I think I got carried. But anyway, so we'll get through it, and we'll see where that brings us. So please ask as many questions as you want. So yes, lots of services. So please ask as many questions as you want. The end goal here is that I talk about stuff that you're interested in. So if I just talk about whatever weird stuff that you really don't care about, like workflows or like data analytics or like stuff that you really don't care, you may care about these things, so just let me know, and then I'll switch gears, and then we're going to go and talk about that stuff. And if I don't have anything in this deck to talk about it, don't worry, I have the other deck that I have done last month and that I'm doing tomorrow that has the 250 features in it. So I can go and have the one slide of it and then talk for the most part. I played with almost all of them, and I have a demo for most of them, but we don't have the time today to go across all of them. So let's get started on the serverless computing, right? So serverless is really about trying, so let me just plug if I'm going to be moving around, I'm going to plug that in. Okay, so the serverless computing is all about you not having to manage servers. That's the end goal. There's certain services of AWS, like the relational database service that I'm going to get into a little bit later, that some may say, yeah, that's serverless. I don't have to manage a server. That's kind of wrong. Serverless is another degree of management, another degree of managed services, where you don't have to think about the fact that there is a server. When you talk about a service like the relational database service, we build a master database and then we build a secondary. So everyone get the master, secondary. So you have to think about these as servers. Once I overload the master, well, there's nothing I can do. I can try to take my queries and try to send them towards the standby or create more read replicas, but you are responsible for doing these kind of things. And then you have to worry about the scalability. You have to worry about what is behind, how many connections can it take, these kind of things. Not having to worry about the server itself, but it is a server, and you have to think about it as a server. Versus if we talk about containers for a second, yeah, you can run containers. We have 2 types of orchestrator. It's ECS, the Elastic Container Service, and EKS, Elastic Kubernetes Service. ECS, for those that doesn't know AWS, that's what we started with. And then Kubernetes came around and then started gaining in popularity. So then now we have a managed Kubernetes solution instead of you having to manage the master nodes kind of thing. So EKS EKS runs and then launches task and pods, or sorry, not task, ECS launches tasks, pods on EC2 instances, but that means you have to worry about the EC2 instances. So what we came out with a few years ago was Fargate. So Fargate is serverless containers, so that you pay for the size of your container, but you don't have to worry about the servers that are behind. We just launch the container whenever that you need it. So the issue that we had was it wasn't working with EKS. Now it is. So we've now added Fargate to EKS. So then if you still want to continue into running and using Kubernetes, which is totally fine, you can use the serverless side of containers, which is Fargate. So you decide. You can either go towards EC2 or you can go towards the serverless compute, which is Fargate in that side. So some limitations around it, so I have them posted there. I think one of the biggest one is the 4 vCPU and 30 gigs. So what are you doing with a container larger than that? But sure, you may have one, and then that's okay. So then maybe that's not the right type of platform for you for the Fargate side. You can have a mix and match though. Like EKS can point to Fargate and can point normally to normal virtual machines like EC2 instances, and then you can move in between the two and have the two of them under the same cluster. The other thing that I thought was interesting was the no persistent volume or file system, which is still true. But that means if you need persistence, you better start saving your data in things like DynamoDB, so a NoSQL data store, or S3, or object data store. So store it outside of just, well, don't store it in your container. It's going to go away if the container goes away. The next one was savings plan. That sounds weird. Why is savings plan? It's a discounting thing. It's about you committing to a certain amount of money and then us reducing your bill. Well, the one thing that I thought was quite interesting of it was the fact that, oh, I forgot to add soon. So and AWS Lambda usage soon. So there's the soon over here. So savings plans applies to EC2, Fargate, and ECS, which means that if you are you commit to a certain usage. So before we had a way for you to commit to usage, but you weren't draining from the amount of, you were committing to a usage per instance, per virtual machine. Now, if you would like to migrate towards containers, well, I'm sorry, you had to use the exact same virtual machines and the exact same size of the virtual machines. But what if that wasn't what you wanted? What if you were changing completely gears? Well, that is the reason why we brought up savings plan, so that you can commit to the same amount of money, but you just drain from it. And then now that allows you to move to containers, but what's still missing from it is Lambda. And then Lambda is coming soon on it. So that was announced at reInvent. The whole savings plan was announced at reInvent, but then to me today, I just want to say that Lambda side is coming soon. Okay, let's talk about Lambda. So who here knows about Lambda of AWS? Okay, good, just making sure. So we're going to get straight into it. New thing around Lambda, so serverless application repository. So this is a place where you can see applications that have already been created with AWS. So kind of using SAM templates, but it can use even more than that. And then if you would like to release it, then people out there could have released their entire project. And you were able to go inside of the console and then go and see the public applications that existed. One of the issue there was anyone can just post them, and then do you really know what is being published there if it's someone that is known? So apparently, so James Beswick is someone that is known around the serverless community. So it will say AWS verified author. So then now we are going to show those in there. So at least we are really sure that the person that is releasing that is actually the person that is saying who they are. So then you can kind of trust more of what that function is doing, what that code is doing. So that's what we added. Now, Lambda has 3 execution models. The first execution model is synchronous. Synchronous, think API gateway, sending a call in, right? A request from the web sends a call in, and it needs a response, right away. The asynchronous event is I just dropped a file, an object inside of S3, and please go and execute whatever is just happened with my file, whatever happened inside of my object. I don't know, generating thumbnails from pictures. I just dropped the full picture in, and I want this to asynchronously send something to Lambda. So you don't know if it actually worked. So you have to worry about maybe some retry logic in there. I'm going to talk about retries right now, well, right after this. The third one is stream base. Stream base is just dependent on 3 services, and those 3 services are Kinesis, DynamoDB Streams, which uses Kinesis Streams, and SQS. So one thing that we have added very recently is the FIFO side, the first in, first out. So SQS has 2 modes, standard and FIFO. We were only able to take from standard. Now we can do it with FIFO and respect the order. So that will be part of it. Okay, so yes. Let's. And then let me go through the next 6 slides, and we'll see if that will answer it. So I think it will, but we'll see. So and then control. So the async control. One of the things that you can do with this. So this is the exact opposite of what you just asked, just so you know. So what that means is, what if I have a Lambda function? What if my goal is I want to try the Lambda, but then if Lambda is not the right tool for what I'm doing, let's say that I need to go above 15 minutes, because Lambda is going to go away after 15 minutes. So what if it's not the right tool for me? I want to fail it. Well, one of the things around failure, if something was to occur, the way that it used to work, well, the way that it still works is, and we have an event age, which is 6 hours, and then we have retry attempts, which is 2. So every time that you do an async event, the async, right, S3 sending the data, or SNS notifying the Lambda to go and do something, every time there's an async call, we will retry twice within 6 hours. Which means that if you want your workflow to actually stop and fail, you have to wait all the way up to 6 hours. It could take that amount of time. What if you would like to reduce it? Hey, my Lambda, if it doesn't work, I've set up a maximum timeout of 30 seconds. And if it took longer than 30 seconds to generate the thumbnail, then maybe the picture that was sent to me is way too large. So we want to fail really quickly and then catch that error, and then maybe spin up a container somewhere to go and do it, and then attach a graphic card to it, and then do it based on that graphic card. So being able to fail quicker. So that's what this thing is kind of doing. So the complete opposite of what you just asked. Now, I'm going to go there, though, so don't worry. So next slide, event destinations. So when Lambda succeeds, so when it's a request response, the success or the error is right there, right? It's a synchronous event. I know it's coming back to me. But what if it is an asynchronous event? Well, one of the things that we had was something that was called a dead letter queue. So a dead letter queue allows you to set up SNS or so simple notification service, which is just push notifications, or SQS, or simple queue service, which is just a normal queue. So you can set and dump your data inside of that queue, or push over SNS. It's okay, but that is only when it fails. When it retried, right? So retried based on what I selected, and then it needs to go and fail. So what we have created with Lambda destinations is a way for you to catch the success and the failures, both of them, not just the failure, but both of them, so that if your Lambda function has succeeded, you can do something from there. So what you need to start getting towards inside of Lambda functions is stop trying to create monolithic application inside of those Lambda functions. Trying to have retry, catch error retries inside of your Lambda function. That needs to completely move out of it. You need to let your Lambdas fail and catch when they fail. This is where destinations can arrive. Now, there's 2 mentality around letting it fail. There's the mentality of using step functions, which I will get into later, that's using workflow. But if you're only working with one Lambda function calling another, or just 2 Lambda functions going one after the other, it's not too bad. You can still trigger them together, and then you can use Lambda destinations to do that. So both success and failure can be caught and removed. Once that's removed, you can send that to another Lambda function, fair enough. SNS, SQS, fine, but also EventBridge. EventBridge is what replaced CloudWatch events. So if you've been working with AWS for a little bit of time, that was what replaced it. But we enhance EventBridge. It is an enterprise bus. It is a service bus. It is a message bus. So we've just put that the fact that, yeah, I have succeeded. The Lambda function has succeeded. So then now you can have any kind of backend that goes and fetches messages from that service bus to know it succeeded or it didn't succeed. And maybe I need to have 15 different applications in the backend that as soon as my Lambda function succeeds, as soon as my code succeeds, I want to notify all of them. Having to modify the code to notify all of these applications in the backend that the fact that it has succeeded, is not the right way to go. So if I just send that inside of my message bus and I have all of these backend applications, whenever that they want to, they go and they fetch the fact that it has succeeded or that has failed. So that's Lambda destinations. Next. Oh yeah, I had some use case. I just went through them talking about it. So announcements for streamed event source. Remember streamed? That was Kinesis, SQS, right? So DynamoDB stream. But the ones I'm going to talk about right now is more specifically around Kinesis streams. And then that will come back to the question that was asked around, well, batching. So where is my batching portion in there? I want to go to my next slide, I think, first. Okay, no, let's go through this one here. So the way parallelization factor, that's the one I was searching for. So PF, what that allows you to do, or sorry, let me roll back. Kinesis streams, the way that it works is you create a shard, and inside of that shard, you push data in it. You can push all the way up to 1 meg per second. Oh my God, 1 meg per second as data inside of that shard. You can catch and get data 2 megs per second out of that shard. That's great, right? That's 1 meg per second. That's not a lot if I'm sending a ton of data. So what do? You add more shards. For every one of the shards that you create, once there is an event in it, we are going to create one instance of the Lambda function going and fetching from that data. So that's 1 to 1. What if one of the shards is getting way more data than any of the other shards? Well, that's not that great. What if I don't have that much data? I want to be able to go and say, just wait, okay? Stop invoking my Lambda function every second, because by the way, that's what happens. Every second, we go and we fetch the data from within that shard. What if you don't send that much data into it? Well, that's invoking your Lambda function constantly. And then that's cost that is associated to it. So what we have created is 2 of these things right here. So parallelization factor allows you to have up to 10 batches on 10 instances. So 10 batches on those 10 instances, what that means is you can now batch and then parallelize you going and fetching off of that data. But data, as you batch it, as you go across shards, is still going to retain its order based on the partition key. Within the shard, it's not all based on the order is not all based from within the shard, which normally that's what it is. Order is maintained within the shard, but whenever you send data within Kinesis stream, you put a partition key associated with your data. So then when you grab your data, the order is going to be maintained, and Lambda will maintain that even if we continue that way. Now, if we continue above, so retries. Now you can have how many retries that you would like to do against your against the records themselves. One of the things that you can do with the amount of retries is and then the other one was the skip of the old processing of records. You can now stop a Lambda function from going all the way back to all the way up to the 7 days of your Kinesis stream to go and refetch the data from the beginning of time of your Kinesis stream, which is really 7 days in that case. So what you can do is you can go and set it to something like 60 seconds. So you can, using this feature, so the skip processing of the max record age in seconds and then the max retry attempt, it can allow you to stop the processing of the current records that are inside of your Kinesis stream. So you can restart it, or you can just discard the fact that it was there. Now, another thing that we have added to it is this weird thing, bisect batch on function error. So if you have records, we're batching records, right? I just grabbed 10 records. Record number 5 fails. What happens now? Well, we're going to retry the 10 records. We're going to retry to do it, and then retry to do it, and then once we hit our retry limit, that's unfortunate. We're going to go to the next 10. Yeah, but there was only one that wasn't working. Well, how is Lambda supposed to know that? It just invoked it with the 10 of them, and then you said you had an error. So what the bisect batch on function error will do is it will play with the record. So let's say the fifth one didn't work. So the way that it will work is it will take, you had 10 records in it, then it will take 5, or let's make it simpler. So let's say the third record doesn't work off of the 10. So it will try with 5. Now the first 5, the third one doesn't work. So the first 5 will fail. The next 5, well, we are not touching them now. We're touching with the first 5. So it failed. We try with 5, it fails again. Now we try with 2, 2 succeeds. We try with the next one, well, the next 2, one of them fails. So then we split it again, and then now we're going to have exactly the failed record. And then we're going to retry on that failed record, and if it doesn't work again, then we'll be able to push it as that's the record that failed. And then we'll start continuing on the other records that actually work from there. So then that bisect batch, whatever thing, is about being able to process the records that weren't working before. So a bunch of announcements on that side around stream events to try to make it easier for processing of those records that are inside of events. Now, one of the things that I really, really want to mention from a Lambda perspective, especially because I'm talking about batching and about processing records from a Kinesis stream, one of the things that seems to be done quite often these days is using Lambdas to transport. Lambda is supposed to be used to transform. If you want to move data from one side to another, you transform. You're supposed to transform, not transport. The transport will be, hey, I want to move data from DynamoDB into S3. Well, that's where Kinesis Firehose is supposed to arrive. Kinesis Firehose allows you to go and dump data on different methodologies that are behind. Using Lambda to do your transport, well, it's good, but it's going to be costly. The idea from this is to try to use your Lambda functions to think about finding other ways than using Lambda for doing your transport and then using your Lambda for doing your normal transform. But then again, it's up to you. Use whatever that you want to use there. You're going to pay for it, so that's up to you. So, function lifecycle. So this is what happens when you launch a Lambda function. It starts with, we download your code. We start a new execution environment that uses Firecracker. It's micro VMs. If you want to look at Firecracker, it's an open source product, and you can go and look at the source code and replicate exactly what we do within Lambda, almost exactly. So when we need to launch this Lambda function, if it's a brand new Lambda, we download your code, we start a new execution environment, place the code on it, we bootstrap the runtime, which means this is your side, so that will be the place where we do the, where you do, I don't know, your database initiation, your database connection if you're doing a database connection. Whatever is before your Lambda handler needs to be executed. And then finally, we arrive to start your code. So if we're talking about a cold start will mean we don't have an execution environment. So we need to start from download the code, execute the environment, create the execution environment, and then start your bootstrap. A warm start will mean that you start exactly from starting of your code, exactly at the time that you execute your handler. So you don't see it. You don't actually see the fact that, yeah, it actually took a little bit more time to execute. It was already warm. So what started happening on that side is that people were not happy, especially around Lambda and VPC. Whenever that you take a Lambda function, you try to attach it to a VPC, that was slow. And the reason for that is we needed to download the code, start the execution environment, and in between here, we needed to create an elastic network interface, attach it to your Lambda function, create an adding between the two, and then now it was available. So that took a lot of time. So what we did is we improved it by making it from 14 seconds to 933 milliseconds. So how did we do that? Well, it's just based on our Nitro hypervisor and our hyperplane that we're using behind the scene. And that is old, right? That's old news. It was announced in August. So why am I talking to you about it? Because it's now available in all public region. It wasn't in August. It was a slow rollout to every one of the accounts. Yeah. If it works too? So if you want your Lambda function to be able to communicate outbound,
I mean, in this case, you doesn't start a new interface. You use one interface for many Lambda execution behind one node.
yes, it kind of uses that particular mindset. Yes. So we're moving the interface and we pre-warm these interface. There's one thing that need to be careful as well, just to add to this new the way that we do Lambda plus VPC is that before, when you launch your Lambda function, when you create your Lambda function, you can execute it right away. There's a cold start. There's that 14.8 second of cold start. Now we need to pre-warm those ENIs that we are going to be able to NAT, right? To be able to have all of these Lambda function that will go and use these ENIs. For us to be able to pre-warm those, it takes a little bit of time. So while we're creating these, your Lambda function is going to be in a state that is brand new, that wasn't known before, and it's not every tools that are out there that supports this new state. So depending, like, obviously, serverless works to be able to go and do that. SAM understands this kind of deployment, but there's a new state that is now in a pending. So your Lambda function is not yet ready for you to execute. It's in a pending state. Once we're finally done creating all of these ENIs within your VPC, now you can run your Lambda function. Well, who really cares about that? You're not supposed to go and execute your Lambda function right away. Well, for devs, you will. You want to test it out. For going in prod, though, well, it will take a little bit of time for it to get ready. And that little bit of time is not that long, right? We're talking in seconds, but we just need you to understand that you're going to see that state. So if your tool that you are using to do the deployment, what it does is it does the deployment, and it tests right away, and then now it fails, and it says, no, it's not working, and retries. Don't do that. Just hold off. You're running it in the VPC. There's a new state. Understand the new state. Wait for the processing to be done, and then start running it. So that could be a breaking change, and then that will be enforced in March of this year. So just so you know, you still have a little bit of time to prepare for it.
I have a quick question. Do you have any plan to add security features natively to analyze the behavior of my Lambda? Because now I need to use a third party to achieve that, but maybe you have something on your roadmap. Or
I'm not aware of it.
I think it's from a security perspective, it's a gap. Yeah?
So
Because now, for example, if one of my developers upload malicious code or something like that in my
in your Lambda function, yeah.
my Lambda function, I have no way to detect if
So-
they have a strange behavior or something like that.
So let me put it another way. How do you detect that from your current servers right now?
Right now, for my current server, if we have a DLP system, for example, we can detect that
So you're detecting it after the fact.
after effect, but I detect that.
So instead, wouldn't it be better if you were in the middle of them doing the commit?
Yeah, sure.
So we're talking about DevSecOps at this point, finally including a security team into the DevOps pipeline. So that's my perspective from it, is instead run it at the time of commit, then at the time of running the test, there should be tests that validates that the libraries that they are using are running against all your suite of libraries that you're okay with. So you're flipping it around instead of trying to bother your Lambda function with that side. Now, doesn't mean that you can't have to do that. If you want your Lambda function to communicate outbound, if you run it in the VPC, now you can, there's something that's called VPC ingress routing that allows you to put your DLP or the packet inspection device in the middle of the packet going outbound. But a request to your Lambda function, the request in, is still directly hitting your Lambda function. Now, the call from that Lambda function inside your VPC or going, if it is attached to a VPC, or going outbound, if it's attached to VPC, you could use this VPC ingress routing thing.
Hold on to questions until the end. Like, he has lots of material to cover.
Okay, no, that's all right. So next one. So cold start problem, right? So I understand that could be a problem, especially if you're running especially if you're running Java and decided to load Spring in your Lambda function. So maybe that wasn't the greatest idea, but what if you really, really, really wanted to use it? So what we introduced is something that's called provision concurrency. So provision concurrency allows you to reserve and have Lambda functions that are warmed at all time. When these Lambda function becomes warm, the way that you do that is you set up a certain amount, and then as you do that, do I have the normal numbers? So let me go through the slides because I have the numbers I wanted to show you. So the way that it works, so what happens in the cold start, we have to do all of these things, right? So if what that means is some of our customers, what they were doing before provision concurrency, what they were doing was keeping their function, their Lambda function warm. To be able to keep it warm, what we were saying is typically we were going to rip away your Lambda function after 15 minutes. So what that meant is your Lambda function is warm for 15 minutes. But that is a time that we never agreed to or said that we will keep forever. We said we will change it whenever we feel like it. And then that may be the time, and it may happen tomorrow, or it may happen in a year from now, but normally we let you know when that kind of stuff happens. But what our customers were doing is creating these weird workflows that were, I have a handler, and then if it is a warming event that I'm getting, I will return, yep, it's warm. If it's not the warming event, then I return my normal data. So every 5 minutes, you had people that were querying their Lambda function to keep it warm. That's okay when I have one Lambda function, but think if I need 1,000 of them. That's 1,000 invocation of your Lambda function concurrently every 5 minutes. And then you're wasting your money on that side just to keep them warm. Yes, there were tools out there that were helping you into doing that. But we understood that, so we released provision concurrency. So provision concurrency, you set up a certain number, and then that number, we're going to keep them warm. When we, back again. When we keep them warm, you are paying for them. So I forgot to put the numbers again in there, but the way that it works in Lambda is you pay in gig seconds. You pay, it's a multiplication of your amount of memory that you have times the amount of time of your Lambda function that you are running, and you're paying per 100 millisecond of your Lambda function running. The more memory you give to your Lambda function, the higher it is per 100 millisecond. So that number, let's pretend that it's around 0.16. It's actually 0.0000, a lot of zeros, 16. It's a number. Now, provision concurrency, we charge you 0.04. So if let me draw that on my laptop. So normal on demand will be, I put it right here. So normal on demand is going to be 0.16. Provision concurrency is going to be always 0.04. So if you're paying for 0.04 at all time. If you don't use it, you're paying for 0.04 at all time. The day that you execute the Lambda function, we charge you 0.08, which means that to use your Lambda function, that's 0.12. So 0.12 is less than 0.16, correct? Which means on demand is more expensive than provision concurrency. But you need to be using this on-demand thing. The number is around 75%. So there's some people that say it's 60, they've made the math, but I just want to be conservative, so 75%. So if you use your on-demand capacity 75% of the time, you are going to be cheaper or as expensive as normally using your Lambda function on demand. That's a weird thing. But how do I keep the 75%? Auto-scaling. We allow you to use auto-scaling with that number. The number of 50 that you have right over here, that's what we use. So the provision concurrency, that number can be moved up and down based on capacity that you're currently using. So just make sure that you play with these. Now, the number that you are using there, so I think I have it right here. So there it is. The provision speed. So you saying I want 15,000 Lambda functions warm right now, you're not going to get it. It's going to take a little bit of time. The same amount of time as if you had 15,000 concurrent customers. I think there's a timer off of that slide. So 15,000 concurrent customers that were coming into you and then doing something against it. So the way that it works with provision speed is we have a burst, so we allow you to run 3,000 of them, And then we're going to start provisioning 500 per minute after the fact. So if you decided that you want 10,000 Lambda function, it's going to take, well, 7, so 3.5, so divided by 2, whatever amount of time. I'm bad at math in English, I'm sorry. So it's going to take a little bit of time for this to execute, right? It's going to take minutes for it to execute. Now, auto-scaling is based on 5-minute capacities. Provision concurrency is based on 5-minute capacities. So you're not going to be able to change your provision concurrency within 5 minutes. You can change it, but it will bill you with whatever amount that you selected in the first place within that first 5 minutes. Then we'll scale up the Lambda function to whatever that you said that you wanted, and then we're going to scale them back down. Now the question is, what if you go above I'll come back on that slide, but what if you go above the on-demand capacity that you have? Don't worry, we're going to charge you based on the on-demand. We're not going to stop it. The only time when we will stop it is if you use something that is called reserved concurrency. Lambda allows you to use a reserved concurrency. When you select that, you say, I want to reserve 100 of that concurrency. When that happens, and we go above the 100, it will stop and throttle you at that 100. So reserve concurrency throttles you. Provision concurrency does not. It allows you to move above. If you do not want to go above and you want to reply back to the client into a, please wait, don't have the capacity right now, then you put both of those numbers together and you set both of those numbers. Okay, so when to use those? So the use cases. So I have two in there. So applications that serve content such as ads or sorry, this is a weird use case. Let me talk about this one first. So weird use case. I have, let's say, content that I need to schedule. I know I'm going to have a marketing blitz. I know I'm going to have a traffic spike. So when those happens, I can directly set it up as a schedule. So that's what I was showing you into this slide here, where you can see that every time that I schedule it, I know that I'm going to need it. So 5 minutes prior, I set it up and I move it to that point. And then I lower it back down and then it's okay. Like now I'm going to be charged the on-demand off of in between 9:10 and then 9:40. That's about where it was. But then at 9:35, I'm pretty sure I'm going to go and increase my amount of Lambda functions to be able to scale to the 2000. And then in between those two times, I am going to be able to go and be within that scaling. And then at some point, I reduce it back down. When I reduce it back down, yep, I have some on-demand Lambda functions that happens again. So that will be in between my 1040 and my 11 there. But that's how provision concurrency will work. Now, provision concurrency is when you don't use that just for, well, I want fun, I want warm starts and all of this. You have to make sure that you use this when you feel the cold starts, when it is starting to happen and you see it constantly and it is impactful to you. It's an async process. Who cares? Just let it do the cold start. That will normally be around when you have API gateway calling in. But if you're calling API gateway to Python or Node, you're probably not feeling it unless you're doing something very fancy inside of your in your headers, or maybe running inside of a VPC where it's adding a few 100 milliseconds of latency. Then maybe you're going to start feeling it there. But other than that, try to stay away from the provision concurrency because there is a likelihood of you paying for nothing. That 0.04, you may be paying for nothing there. So just be careful on that side. Okay, provision concurrency, that's what that was. Lambda runtimes, we did some updates there. So it's now based, well, it has been based on Amazon Linux for a little bit of time, but Amazon Linux 2. So Node.js 12, 11, and 3.8 are in there. And then there's one thing that I really, really wanted to mention that happened really recently, is a change to Boto Core. If Boto Core is what is behind the Python SDK, and then as well as the AWS CLI. Boto Core, when we first released it, we needed and we were using the request library. That's an open source request library. One of the issues we had when we were using the requests library, which is an open source version, was they were really slow at deploying what we wanted. So what we did, and because we wanted it to be deployed globally way faster, we created something called a vendored request library. which we named that way. It was, if you wanted within your code, you could have done an import vendored.requests. And then that was request that was right available to you, and it was already bundled in the AWS SDK. If you've made that mistake and are currently using this, you need to change now. Because as of March, we are not going to include it inside of Boto Core anymore, because we have now shifted from using request to URL lib3 directly, instead of using the request library as the overlay. It's been a while since we've been using URL lib3, but then now the request library is not going to be in there. Now, why do you care? Well, you may care if you use Lambda function and you do not include the Boto 3 SDK with your code. And I know that inside of the Node runtime and the Python runtime, we include the SDK. But this SDK, we can change it anytime. So the best practice around here is when you create and when you code in Node and Python, even if the Boto 3 SDK and the Node SDK is already included in the runtime of your Lambda function, include it with your code. I know it adds more space and it does increase the space of your, or increase the size of your package, but that's the proper way to do things. Because if we decide to change the Boto 3 SDK version behind the scene, and then today your Lambda function is working and tomorrow it's not, well, you can't complain to us on that. You just were expecting that the library was there. So just make sure that you include the library that you need as part of your code. So I hope no one is using the request library that was vendored inside of the Boto 3. If you're using just pure requests, just include pure requests with your code. That's all. And if you really, really want to continue into the way that you were doing already, so what we have included is you can use a Lambda layer. So the Lambda layer will have that included into it. Okay, so that was all of the announcements around Lambda. The next ones I want to talk about is around workflows. So workflows. A business workflow may look something like that, right? It's not just one Lambda function I'm executing. When I arrived in and then I'm doing something, that something may be just running EC2 instances, or maybe running a container, maybe running a batch of instances, maybe creating a model for machine learning, or not. It may just be a normal Lambda function, but then that arrives in and then we have a parallel task that is happening, then we need to be able to handle errors across it. And trying to do that from one Lambda function calling other Lambda function is not the right way to do it. So what we had and what we talked about was step functions. Step functions is your way to be able to create that workflow and ensures that you're able to call each one of these Lambda functions and create that workflow and handle all of these errors as they're playing. So step functions, that's what it is. So if you don't know what it is, it's a workflow process. It has tasks within it, and then those tasks are being done by machines that are behind the scene. Those machines are other services of AWS. I'm going to talk about the integration in a moment. So it's actually, it used to only be able to call Lambda for a very long time, but it is not just Lambda anymore. And I'll show you an example in a second here. So yes, you can use step functions plus Lambda together and then create these kind of workflows. Each one of these green boxes that you see are a Lambda function that gets executed. And then if you see that, hey, image type check, it's not supported, it goes to not supported image type, and then that is a failure. And that can be sent back towards where the customer is at. So that's great, but one of the things that happen with this is maybe sometimes you're doing stuff that needs a little bit longer time than just running that on pure Lambda. So what we did is we added quite a few integrations to it over the years. And then you can see a bunch of them here. So yes, it can talk to SNS, but it can also dump data inside of a queue. So as part of your workflow, you dump it in the queue. Then the next step is maybe having something else that goes and pops the data off of that queue. That something else may be, I don't know, executing AWS batch, so a batch of EC2 instances going and running a certain script. With normal step functions, you can say, hey, batch, go execute this, and I'm going to hold off. I'll hold off until you're done with your batch. That's normal step functions. What is new is we added EMR. So EMR is a Hadoop managed Hadoop environment. So you can go and execute your entire environment and go and fetches whatever that data is, and it will shut down your cluster if you want to, or go and execute something within your MR cluster. We also included something that is called SageMaker. So SageMaker is our machine learning pipeline, so service. So then you can create a workflow process to say, hey, data that I use to train my machine learning model has now drifted from the data that I'm currently using for inferring against this machine learning model. How do I detect that? It's a new announcement in SageMaker. It's called SageMaker Monitor. It allows you to understand that drift. So what do? Well, now I take that data and I kick off a new workflow for training a new model. So that's all part of normal step functions. So that's all good and great. That has been there for a little bit of time. But what we do want to say is less code is better than more code. So less code, by being better than more code, what we mean is going and directly integrating with the services instead of trying to do it on your own. Right? So trying to create Lambda functions and having a Lambda function that calls the other service, that's an anti-pattern. The right pattern is getting step functions to call the right service, to go and do a batch job. So stop putting Lambdas everywhere around your workflow and try to find if the integration actually works and it's able to go and get it. But it's okay. You can use Lambda plus step functions. We're okay with that. And then that's where we're going to go next. That is right here. So step functions has now two modes. Step functions express workflow and standard. Standard, we listen to you. We understand that it had a certain limitations, like having about 2,000 request transactions per second was the maximum around it. If you're thinking about, I have a ton of Lambda function and I'm trying to execute them, and I'm using my workflow process to be able to try to handle all of my errors, but I have so many microservices that are calling other microservices that I'm all putting them inside of that workflow machine, and it's slow because it's taking only 2,000 events per second. Now we have express workflow. Express workflow can go to 100,000 events per second, and it's cheaper. So let's go and see which one is right to use. So I have some examples here. So event-driven microservices orchestration, that shall go towards express workflow. Things like payment reconciliation, order card validation, high volume data processing in express workflow. One of the reasons for that is we do not keep a log of the data. So if you have PII data that is moving in between each one of your states, in normal standard workflow, there's a log of it. In express workflow, there are no logs. And the main reason for that is because in standard workflow, we save data to SSD in between each state. So if there is an issue, we will be able to recover. We are going to be able to execute always once. With step functions express workflow in memory only, which means if there is an issue, we will re-execute the entire workflow. So maybe that's not a great idea for something like payment and billing. Maybe for order processing if you're not idempotent in your code. So that's step function express workflow. I have a bunch of differences between the two right now. But first, the console, the state machine definition, and documentation are exactly the same. Nothing changes between the two. But pricing, standard is price based on state transitions. So if you had 50 Lambda functions that were all executed one after the other, and that whole thing was executed within, 30 seconds, well, you were priced by 50 times because it was 50 state transitions. Versus Express, you pay for like Lambda. It's very similar to Lambda. Instead of being gig seconds, it's gig hour. So you pay by the amount of execution and the duration multiplied by the amount of memory that you use for your step function, which right now most people are running within the default at 64 KB, but or 64 megs. But if you go above that amount, then you're going to run into going one step higher, which is going to cost you a little bit more money, but it is all similar to how Lambda works. So step functions express workflow is actually going to be cheaper for orchestrating Lambda function than the previous version of where you were being priced by state transition. Now, maximum duration, standard is 365 days versus express is 5 minutes. So there's a huge difference there. We want express to go fast. It says express in the name, right? Go fast. Start execution, way higher in terms of bucket size. So you can execute 6,000 of them. And then there's a refilled rate of 6,000 per second. So you start with 6,000. And then if you need to execute more, then every second we're going to add another inside of the bucket for you to be able to execute more of those executions and get to the 100,000 transactions per second like we said. State transitions, it's unlimited on the express workflow versus there was a limit on the standard workflow. By the way, the numbers that I have here are really based on the North Virginia number, Ireland and Oregon. The others are a little bit lower. All of the other regions are a tiny bit, well, somewhat lower in there, like 800 I think is the number for that one. Execution semantics, really important to understand, like I mentioned, exactly once workflow for standard versus express is at least once. You need to be idempotent on an express workflow. We may execute it more than once. If there's a problem inside of the service, if the backend is going away because this is in memory only. So we're going to have to restart the entire workflow. So you need to be able to handle the fact that it was a huge workflow. So maybe if you're doing an 8-hour workflow, and then because you were transcoding and doing something in there, using express workflow is probably not the greatest idea there. So because if we have to restart it, that's another 8 hours for it to restart. So yeah, standard is probably the right way there. Executions. So the one I really want to go towards was the service integration. Every services that I talked about a little bit earlier are supported with standard, that's normal, but with express, every one of them are supported, but activities are not supported. An activity is something like I want an external worker to go and do something. So I create an activity and I say, I make it available, and then I have someone that comes in and pulls the activity and say, hey, I want to do some work. Do you have some work for me? And yes, I have some work for you. So it executes that work. It comes back and says, yeah, I have executed that work. That's an activity. That is supported in standard, not in express. In the pattern size, standard supports a job run and then a callback. Those are two newer types. So a synchronous execution of a job run, even though we support all services, if you think about AWS batch, we want you to execute on all of those EC2 instances. In a standard workflow, it will wait for the execution to be done. So it will execute a .sync. It will be a job run. Go execute and then come back later. In an express workflow, what it will do is go do the work. I'm going to the next step. That means that it may not work so well for a batch workflow. Or maybe you just wanted to start it off. The next one is a wait for task token. A wait for task token is you execute, let's say, a Lambda function. The Lambda function goes out and gets a user to approve or disapprove of manual approval, and then that goes into an email. Then that person clicks on the link within that email. That sends a callback with a token to step functions through the API, and then that says, yep, I have executed whatever that was. Similar to how activity was, but instead of having to pull it, you can now stop an execution in the middle of your workflow, go and do some work, and then execute it right after. Well, that is not supported in Express workflow. It is supported in standard workflow. Okay. That was Express workflow. Oh, yeah, and then you can also tie the two of them together. What if you want the two of them? So you can now tie a standard workflow and get a standard workflow to execute an Express workflow. An Express workflow can also call another Express workflow. So yeah, that's what we also added. Okay, that was step functions, that was workflows. When I go to the next one, event-driven architectures. So let's talk about them. We're moving, right? Moving from monolithic to microservices. Tons of microservices everywhere. So tons of microservices talking to other microservices. What that means is it's easy when I have a producer, a consumer, and I'm trying to post in between the two. That's not too bad. Then when I add two of them, that's okay. The producer just needs to know about all of the consumers, and the consumers needs to tell the producer that they exist. Not too bad yet. And then that starts occurring, and then it gets worse and it gets worse. So that's why you need a router. You need a router in the middle. It's an event router. We have, or a message bus. That's normally what the name, or service bus are the terms that are being used in the industry. So we have EventBridge to help you into doing that. So with EventBridge, so fully managed on that side, 17 target services. But the idea is you send data into it, and in EventBridge, you can have others that comes and pulls the data from within that EventBridge. That also includes, so if I look at the event sources, they can be AWS services. So I think when I counted, there were 60-something services that are all tied with EventBridge, so they can all send an event. Like EC2, I'm done booting. Or like Lambda, wanting to send something in there. Or, hey, we have a new service that's called Augmented AI. Augmented AI, what it allows you to do is you can deploy a model into production, and then when the model is in there and it's the percentage of confidence is lower than what you wanted it to be, then it can be sent to a human. So then now you bridge a gap between humans and machines against models, and that's called augmented AI. But then maybe you would like to know that, yeah, it actually didn't meet the percentage of confidence that I wanted in the first place. So that can be an event that is sent as an event source. We have SaaS application, that's third-party application, like Zendesk, Datadog. Like you have a ticket, you want to click on that ticket, and you want it to be an event that occurs in there, so it's an event source. Or custom application that just calls and then sends functions in there. On the target, like I said, 17 different targets that exist out there, but it also has SaaS application that can be used as targets into the backend. Now in the middle is the event bus, and then when you create your event bus, you can set up something that is called rules. The rules, the goals that they are, so if I say that I have Lambda, Firehose that are attached to rule number 1, step functions on rule number 2, and then SQS on rule number 3, I have all of these events on the left-hand side that are sent by all my event sources, that are sent into my event bus. But each one of these rules gets applied, and then I know that, hey, apparently rule 1 will match, rule 2 will match, 3 will match, but not 2, which means that the event will be sent to the others and then not in the middle. So you create rules to say what you want, so kind of like filters. You apply filters based on your data that you have in there. So if I look at event, it may look something like that. It's in JSON, arrives, I have my details at the bottom. That's all good and great. I can create my filters, it's good, right? It's all there. But then how do you know what's in there? Like your producer may change what goes into the event anytime that they want. So then now you need to have a documentation somewhere. Yes, you're supposed to have documentation. You're supposed to have something that includes what is going inside of that event bus. But what if you have a backend, that backend is ready to go pull something from the event bus, and then now you need to supply another API call or another API backend that will allow for someone to go and fetch what is the type of data that you are submitting in there. So that's why we introduce something, so how do I manage all of these event types, like order, created, loyalty, registration, payment, receive, all of that being sent inside of one event bus. How do I know how they are all being done? So you need some kind of documentation, and that's why we included something called EventBridge Schema Registry. The EventBridge Schema Registry, its job is to document the type of events that are being sent in it. So you create that schema registry, you can go and then from your consumer, you can go pull that schema registry. You can go know exactly what's the type of events that are inside of it, what's the type of data that is inside of it. Another thing that we have added as part of schema registry is something that is called automatic schema registry. So you can enable that. When you enable that, what actually happens is as you send data in, we will look at that data and automatically create the documentation, the schema documentation in the schema registry, so that now your consumer can go and pull whatever that was in there. The other thing we've added with the schema registry is it's integrated with some IDEs, and then so VS Code and IntelliJ, but it generates code bindings for Java, Python, and TypeScript. so that you can download these right away and then just include that inside of your package, and then you don't need to worry about the transformation, about taking it from, well, it was a string and then now I have to convert it into an integer and then do something with it. So all of that is being done for you as a package that you can download. You include it inside of your environment. The fact that it's integrated with these two IDEs, it just means that from these IDEs, you can say, create me a new project, and it downloads the code bindings for you. If you don't use these, but you use these languages, you really should be using these. But if you really don't use them, then you can still just download the packages and then include them inside of your project. So pricing of it, which is pretty great. Registries, they're free. So use them. So use it as your documentation, querying for the data and going and fetching them, that's free. What isn't free is the schema discovery. So you have 5 million ingested events per month. That one is perpetual, so it stays there, of free on that side. Now, if you are sending quite a lot of data within your EventBridge, that may not be the right way to do it and always having Schema Registry always turned on. Maybe having Schema Registry turned on for your dev environment, and then when you're ready, you take and you can go in the console or via the CLI, download the entire Schema Registry, and then re-import that for your production environment. So then you don't have to turn it on in production at all time and then pay that cost. But if you do turn it on at all time, well, there's a cost associated with it. So that's Schema Registry. Okay, next. We just talked about modern applications serverless, right? Serverless application. We just talked about provision concurrency. Provision concurrency, what does that mean? It meant that I have Lambda functions that are always up. Relational databases. Do you think your relational database are going to like having 10,000 connections that are open to them at all time just for the fun of it and then sometimes it's being used? No. We're supposed to use connection pooling. We're supposed to reuse these things, but Lambda functions don't talk to each other. They don't tell the other, hey, I already have a connection in there. No, you establish it in your init phase. So that's an issue. It's a relational database service. If you don't know what it is, that's our managed service for all of these types of databases. And then we have one, it's called Aurora. So it's our take on MySQL and Postgres. So that's our side. We do some kind of fancy stuff on that side. One of the things that we have added last year and then that we improved in quite recently is, this thing right here, Aurora Serverless Architecture. We have Aurora Serverless. That's our take on Postgres and MySQL, like I said before. But Aurora Serverless, the way that it works is we can scale the request router and that scalable DB capacity individually than the database storage. In normal relational database, you have the compute and the storage. They're stuck together. You want to make your master faster, you grow it up, right? You make it bigger, a bigger instance. You don't grow it sideways. Because growing it sideways or horizontal scaling means that you're now doing multi-master. Yes, Aurora supports multi-master, but in some of the other types of database, it doesn't work that well. So Aurora Serverless, its job is to scale the database capacity, the compute, based on the amount of requests that you're sending, and then lower it, well, based on the amount of compute that you're not sending anymore. That's Aurora Serverless. So that's old, right? That has been there for a little bit of time. But what we added this year was something that is called the data API for it. So the RDS data API, which works with serverless, what that does is it allows you to do HTTP requests to your database, not SQL connections. That is also old, right? That happened this year, at some point this year, right? That's old. But something that we've added is we have now a Java client library. So this one is a little bit newer on that end. But the data API is how you solve your issue with scaling your serverless application for normal relational database you have in the backend. But what if you really, really have a normal database and you don't want to use Aurora Serverless? So what we've added is something that is called RDS proxy. RDS proxy is for one type of database, MySQL. So RDS MySQL or Aurora MySQL. We are working on Postgres. I know everyone wants it, but right now, MySQL. What this does is it creates a proxy in between your Lambda functions or your client and your database, which means you can open up 10,000 requests to your RDS proxy. In the backend, it will reuse this connection to it. which means it's going to use something that's called connection multiplexing. So by being able to do that, we have way less connection to the backend, way less connection to the database means we don't have to grow and make the database bigger and bigger and bigger. So you're not paying for your database for nothing. That's the goal of RDS proxy. Now, some nice stuff that it allows you to do, and it is something you really should be using, is something called IAM authentication. So normally when you talk to in a relational database, you use a username and a password. Great. Yeah, we now support AD integrated with MySQL now, and then we support it for Oracle, and then we also support it for SQL Server, and we've done this support for SQL Server for quite some time. So fine, like we support that. But Lambda is not tied to AD, so you're gonna have to put credentials. Where do you put those credentials? I hope you're storing them in Secrets Manager. Right? I hope you're not storing them and hard code them inside of your code. If you are, please stop and then go use these other services. The thing that I wanted to talk to you about is something that's called IAM authentication, which has been there for quite some time, but I want to reinforce it again. You can use an IAM role, the role attached to your Lambda function, to call Secrets Manager. I have it somewhere almost there. Here, so from your Lambda function, you request a token to IAM. IAM will return you back a token. You use that token as your password that you then send to the normal relational database that is in the backend. With RDS proxy, you can enforce that. So you can now say you must connect to me over and using IAM authentication. The backend is going to be using normal authentication. And this normal authentication, the credentials are being stored in Secrets Manager. So the workflow works this way. Starts with step number one, from your Lambda function, request the token. IAM will return back the token, so it's actually STS that returns the token, the security token service. You use this for your connection. You talk to RDS proxy. How do you talk to RDS proxy? It's just a different endpoint. Instead of being the endpoint of your database, you're just using the RDS proxy endpoint. Talk to it. RDS proxy now validates it, goes to your Secrets Manager that you have associated with it, goes and fetches the database credentials of the user that you use to be able to do the call in the first place, gets them back and establishes a connection towards or MySQL or just plain MySQL in the backend. So that's RDS proxy. Does that make sense? Okay. Okay, next. The goal is to bring it for Postgres, yes. They didn't tell me, so I'm too public facing. So, but they did tell me that Postgres was coming. They didn't mention it at reInvent, so that's how I can say it. So, but yeah, they never tell me anything anyway.
Enforced behavior is for requests coming from Lambda only or from other clients?
To the proxy, if you want to. You don't have to do that, right? You can just decide to say, no. I just want to use normal connections. The normal has how I've done it before. You can continue on doing that. That's totally fine. So yeah, you just create more than one proxy for enforcing that behavior if you wanted to do that. Now, the RDS proxy, the thing around it that I didn't mention that is pretty useful is failover. You know, when you fail over between databases and you go from the master into the standby, there is a connection drop. And that connection drop is not fun, especially when you have to reestablish it during that time. Well, with RDS proxy, there's no connection drop. It will automatically move that. There's no DNS request and DNS cache worry to have because RDS proxy is responsible and understand that it has moved and it's already pointing towards the standby itself.
His question was, does it have to be from Lambda only or it can be used from other?
Oh, I know. I was just adding yet another topic to it. Yeah, the answer to that question is it can be anything that you want. Yeah. But yeah, I just have way too much to add. Here's how it will work. No password embedded in code. So you, from your endpoint, you do a token await signer get auth. So that's how you talk to STS to go and get your token. And then that uses the role. Yep.
What about the in terms of size?
So the thing that was one of the reasons for not using IAM authentication before directly to the database was because there was a limit on IAM authentication, the amount of connection you can establish on IAM authentication. Now with this, there is no limit on the RDS proxy side, and your backend uses normal authentication, so you're not suffering it in your backend. So here, so you can do, so STS does not really have a top limit end. So the limit is there to try to protect our services from what you're currently doing. All you have to do is open up a support ticket and then get that limit raised. So that's why I say there is a limit. Yeah, there's a default limit. I can call it that way. True. Open up a support case. It's just so that we protect our services if you're starting to do too many weird stuff. But around this thing, well, the whole idea is your Lambda function are going to spin up. They're going to execute this thing. But the whole point is to have that in your init phase, so your Lambda function stays, and you don't redo it every single time, because that's adding latency. Like doing this call adds latency than just going and using your passcode right away. So that's why this could work really well with provision concurrency. But then that means you're not hitting STS as much. So the security token service as much. Okay. Next, where it is at. So like I said, Postgres coming soon, and it is only for RDS MySQL right now. And this does not work with Aurora Serverless. You want to talk to Aurora Serverless and then, well, use other ways, just use the data API. Don't use the via normal SQL there. Okay, API Gateway. Do you need all the features in API Gateway? Who here has used API Gateway? Are there too many features into it? Yes, there are too many features. Do you use them all? Yes, it's expensive. So what if we could have 67% cost reduction, 50% in latency reduction? Why? How do you do that? Well, we just give you less features. Less features, it becomes faster and cheaper for us, which means we pass the cost saving, and then that's it. That becomes more helpful there. So that's exactly what we did with HTTP API Gateway. So I created that table to try to show you the difference between the two, which are quite strange in there. But the one that I want to really highlight is that authorizer. The authorizer on HTTP API only supports OpenID Connect. But wait, it supports OpenID Connect. Finally, you're not stuck with the authorizers anymore and then having to do OpenID Connect via Lambda, because that's currently what you have to do. So then now finally we support it. And then yes, I say Cognito here that it's supported, but Cognito can issue GWT token, which comes back to a native OpenID Connect in any way. So that's the only authorizer it supports. Other thing is extra security features. Do not think that by extra security feature, I try to modify that thing. I say none on that side. It is not less secure. The thing I'm trying to say is it does not have these features. These features are client certificate, authenticating API gateway to your backend. HTTP API doesn't do it. WAF doesn't integrate with it. Resource policies, to be able to put policies into what are all the IP addresses that can communicate to this HTTP API, doesn't do it. Domain names, so API keys, it doesn't support it. In the custom domain names, HTTP API does not support wildcard domain names. HTTP does not support pure normal HTTP, you playing with the request, doing private integration, which means inside the VPC. AWS services does not support that. The only thing it supports is proxy HTTP and proxy Lambda. It does not support VTL, and then that's my next slide there. Does not support transformation. It does not support validation. It does not support test invocation. It does not have a cache. What does it support then? Well, it has a Lambda proxy and HTTP proxy. If that's all you were doing, then yeah, it's totally enough. Now, HTTP API, it supports something called CORS. Wait, what? CORS, cross-origin resource sharing. REST APIs was also supporting that. Yeah, it was a nightmare. You had to go create the options by yourself and then go and trying to figure out what you're going to return as data. And then your Lambda function needed to have the data as part of headers that were now being returned. This does not. You just go into your API and you say, I want to enable cores. And then you say what's the domain you want to do. It will handle the options for you, and it will handle bringing back in the GET request the right headers for you. So it makes it way easier. Things like automatic deployments. If you've played with REST API, you will know that, oh my God, why isn't this working? I'm sure I have the right thing. And then you realize, I forgot to deploy. That has the automatic deployment if you want to. Default stage, default route. Default stage, if you do not want to have a stage within your URL, you can have it as blank and it will go to some place. Default route, if none of the current path that you have selected matches what you're trying to do, you can have a default route that points towards, let's say, an HTTP proxy or an HTTP backend or a Lambda function that you have somewhere. So you have a default route, a catch-all, if you per se. API types, HTTP API only supports regional, so it does not support having CloudFront in front of it, but you could still create a CloudFront distribution in front of it yourself. It does not support a private API, which means if you want to have it internally inside of your VPC or reachable via inside your VPC, it will not be possible on that side. On the monitoring side, it only supports CloudWatch logs or access logs to CloudWatch and metrics. It does not support X-Ray, does not support execution logs, nor data streaming those into Kinesis Firehose. Okay. Creating those APIs, it already supports CloudFormation. Wow, I know that's so. And SAM, as well as it uses the OpenAPI 3.0 model, so you can create and then if you want to migrate from your current REST API into this, you can export in OpenAPI 3.0 from the normal REST API and import this data into your HTTP API. Just note though that you can't export from your HTTP API. You can only export from the REST API. So that maybe that's a feature. If you want it, just ask for it. It's in a preview state right now, so it will change, and then you can, yeah, she'll be pretty good. So here's an example of the latency example. That's a weird thing that I'm trying to show there. So let me just try to explain it. So in this graph, I'm showing the amount that I sent into that API. The integration latency you're seeing, and in the latency, the actual latency of API gateways, you need to subtract these two amounts. So the latency is the overall latency that we have received. The integration latency is what the backend took amount of time. So 68.7 is the amount of time that my backend took to execute my Lambda function or my HTTP proxy that I'm doing. The latency that I'm getting is the overall total latency that I have had from HTTP API. So if you look at it, what is that? Like 1.2 millisecond? That's actually pretty good for API gateway. So that's way faster than normal API gateway there. Okay, next. Ooh, that's weird. I forgot to take out that slide. I already talked about it. So Amplify, two new things around Amplify that I wanted to talk about. So those two are, the first one, the Amplify for iOS and Android. I know that if you went into the Amplify CLI, it was there, but it was not real options. The options existed, but it wasn't doing really much there. So then now, yeah, we do actually have it. And one of the things I want to talk about on the iOS side is iOS has machine learning in it, has some artificial intelligence, being able to do things like facial recognition will be an example, or object detection. It already has that as part of the core OS or core ML of iOS. But we also have certain services. So what if you would like to merge these two results? Well, Amplify for iOS predictions will do that for you. It will actually use the result of what the local device has done, call our services within one single call that you're making, call our services, merge the two results, and give you the highest positive from the both of them. If you're offline, it will automatically just pick up what is normally on the device. If you're online, then it will make the call towards AWS. So that's part of the Amplify for iOS and Android. And then the other thing we've added is something called Amplify Data Store. Amplify Data Store works with Async So it uses GraphQL, but the idea from it is for you to be able to have a data store that is not stored in AWS, but actually stored, so data stored on your devices. But if you have an iPad and an iPhone, for example, and you would like to share data between the two, now you have to worry about syncing this data between the two. And what if the iPad did something and then the iOS device just went in the elevator and then just popped out of the elevator, like merging these two together, playing with the synchronization, that is a little bit more problematic. So it is something that you have to handle as part of your code. With the Amplify Data Store library, we're doing that for you. So we're integrating directly with Async, and then we're making these merge for you, understanding like those delta sync, the auto merge will be all part of it. The data is not stored in AWS. The data actually stays stored on your devices themselves. So those are the two things I wanted to talk about Amplify. There were a lot more, but those were a little bit before reInvent, so I didn't include them. Now, DynamoDB, or NoSQL Data Store, it's a serverless service, so I thought I will include a few of the things that we have added to it. Server-side encryption using CMK. So DynamoDB has been supporting server-side encryption for quite some time, but that was using either our key, and at some point we added the fact that you can use a key inside of KMS, but a key that will be AWS managed, that you created from AWS. But what if you created a key on-prem, and then you would like to use the key that you have created from your on-prem device? Well, you were not able to do that until we released this thing. So it's KMS Customer Managed Key. Now you can do it. The next one is something that I don't know how many times people have asked me that. So before I was, like I said, before I was a dev advocate, I was a trainer, and I used to teach a class that was called Developing on AWS. And one of the things that I kept telling people is everything about hotkeys, everything about a hotkey inside of DynamoDB will be, well, let's roll back. Databases. Databases, the way that they scale is there is vertically, but once you reach a certain maximum, you have to scale horizontally. To scale horizontally, that's called sharding. You shard your data across each one of them. In DynamoDB, that's called partitions. You partition the data. Now, for us to partition your data across all of these partitions, we use your primary key to do that. We use a hash of your primary key to go and send it in. Now, one of the issues with that is, what if you're always hitting the same primary key over and over again? How can you detect that you're actually reaching your top limit? You may keep increasing your amount of provision concurrency on writes per second, or write WCU and RCU, so the writes per second, the reads per second that you're doing against your table. You may keep increasing them, but you're paying for nothing because you're just hitting the maximum amount of your partition, and we can't do anything about it. So then what this does is it finally shows you identify the frequently accessed keys and the traffic database trends. So it's trying to be helpful on, this is your hotkey. You seem to be constantly hitting that hotkey. Why? Maybe it's one record that you query before querying anything else inside of your table. You may not have known that. Well, we had some clients that is exactly what was happening to them, and they kept being throttled and they didn't understand why. But it was just a test username they created, and as part of their normal execution code, they were making a query to the test username before making a call to the normal usernames, and they didn't know, never noticed it until, well, our team, because we were able to generate some of these graphs for you, and then we were passing that back towards the customer, and now the customer knew about it. So then now we have a way for our customers to see these graphs directly. We've taken it one step further though, and we created something called adaptive capacity, which existed before, but then now what we're doing with this is we will automatically repartition based on the frequently accessed items. Before, we were automatically repartitioning based on the size of your partition, and then we were never repartitioning unless you were increasing your amount of WCU or RCU. Now, we will repartition, we will shard based on your access pattern, which means that you should see a lot less of these red lines and mostly access and frequent access in there. But then these graphs are still useful for knowing what are your access patterns. So I thought those will be the three most important cases for DynamoDB because I thought they were really interesting. So this one is GA, so general availability, while the hotkey identification is still in preview.
Is it on by default with existing tables or only new tables going forward?
Existing table now. Yeah. So main table and GSIs, right? GSI is another partition anyway. So, so that's why we need that as well. And yeah, so no additional cost for it. So yeah, that's why it's on by default. And with that, that's my last slide, almost last slide. So 2020 and beyond. So this is what we're saying about serverless. So I grabbed that from Chris Munn, right? So that this is what he was telling us. On the serverless space, we want to do these, right? Equipping developers for improving tools and monitoring. We've already done that. We've improved a little bit of what we were doing with Sam, but we want to grow on that side. So more efficiency to dev patterns, right? So the new patterns around events, like pushing people to stop doing error handling within Lambda function, pushing that out. You're going to see a lot more talks about that, a lot more prescriptive around that side. A lot more prescriptive around what we say is the right way to do things. You don't have to listen to what we're saying, but yeah, so you're going to see a lot more of that coming into 2020. A lot of the services I've talked about today are in preview, so that's why it is 2020, it is future, because RDS proxy, it's a public beta. Don't use that in prod, so it's public beta. There is other services like the DynamoDB one I just showed you. One of them was preview. A lot of the services, I normally wrote it at the top right corner. So once you get the slide, then you'll be able to know which one were in preview and GA because I wrote it at the top. But that's our 2020, getting those out of GA. Getting those out of preview and into general availability. That's more or less of the how do you know what is coming down. So there were a lot more announcements, but not really pertaining to serverless. So I didn't think I will include those. And then with that, I want to thank you. But before that, this thing over here will get you to fill out a survey. If you give me 5 on 5 on every one of the questions, you're going to get a $25 credit. No, don't worry. You're gonna get it anyway, right? You answer what you want in there, and then please put comments. That's always helpful. The code, you're only going to see it once, and then this code will only be, this page is only valid until 11:59 p.m. tonight. So look at it. And then I have a bit.ly link over there. So every reInvent sessions are on that page. So someone created it from my team. And then there's a podcast icon next to it. So instead of listening to them on YouTube video and using our precious bandwidth that we have in Canada, you can download them as podcasts. So all of them are there. And I really love the fact that I can just do a Control F and search for a session instead of trying to do it via YouTube and then find old sessions and stuff like that. So I thought I will include that link because I think it's quite interesting. If you have questions, I'm here. Other than that, you have my contact info. I always answer whatever is being sent to me on LinkedIn and on Twitter. So please feel free to add me. It's okay. I don't post much on Twitter. I do post a lot more on LinkedIn. Seems like Canadians are more on LinkedIn than Twitter, but we'll have to change that somehow. But yeah, and then this deck, I know it's an empty line, but I'll get you the deck and then we can send it as a link. Awesome. Well, thank you everyone.
January 20. This was amazing. Thank you so much. So guys, we were allowed to stay until 9, so you have another 28 minutes to mingle, ask questions. If you have any questions right now, he's still here. Mike, I'll walk Mike around.
Yeah, so I read about AWS FireLens. Was it launched with this year as well?
FireLens, yes, that was around the CloudWatch, right? No,
That
FireLens was around containers.
yeah.
Yes, it was launched, and they did say stuff about it, but I don't even think I have a slide around it. So, oh yeah, sorry. So yeah, it was launched. Yes, I've seen it. Because it is how to integrate with your containers to be directly throw your logs into CloudWatch. And I know it works with ECS, but I can't remember if that works with EKS as well. So I'll have to double check that one. But yeah, is it that of an interest to you, for that one, for being able to throw your logs directly into it? Okay. Okay, fair enough. Yeah.
Thank you a lot for your for such information. And I have a question. What about direct integration between API gateway and RDS data API? Like it can do with DynamoDB, for example. We can attach directly DynamoDB to endpoint and execute simple CRUD just directly without any.
So I can't remember if AppSync can do it. So, but data API is only Aurora serverless, right? So for the moment, so you would want API gateway to the data API within Aurora serverless, correct? Okay, so okay, I'll take that in note on that side, and then see, and then just try to create a product feature request on that side. I have no idea if that's coming, but that's an interesting one. I don't know why.
It exists for DynamoDB, for several other
yeah, it supports a lot of services, but that specific one, no. But then I don't know if if AppSync supports it though. I don't think so. I think it only does on the data store, like Dynamo and then Elasticsearch. But yeah,
it's slightly another story.
Yeah. Fair enough. So it will be API gateway, right? Not via a graph, not via AppSync, right? Okay. Okay. And is that will that be to be able to do things like throttling, or like what will be the reason for why putting it in front of API gateway instead of querying it directly?
Because of optimization, because of predefined models, data validation.
Okay. Okay, so the full REST API kind of thing. Okay. Okay. Fair enough. I'll put that. Sorry, where's my notepad?
Any other questions? No? So we can start the mingling then. Thank you so much.
Awesome. Thank you.
Thank you.